Welcome to Matematika. Today we're going to do the part 2 of polynomial functions and rates of chains. In this video, we are going to have a lot of information, especially with the definition of terms about the local and global extrema. So we'll start with the first term. Extrema are the highest and the lowest points of a function within a specific region or overall. A local maximum or local minimum is the highest and lowest point output value within a small interval of the function, while the global maximum or global minimum is the highest or lowest output value across the entire function. Every global extrema is also a local extrema. Extrema occur when the function switches between increasing and decreasing or at the included endpoint of a polynomial with a restricted domain. Let's look at this and summarize this definition and see how it looks like within a graph. Okay. Local, sometimes the term is relative. Okay. Extrema, that means it could be a maxima or a minima. Minima, maxima if you have only 1 point, or minimum, maximum if you have several points. If a polynomial switches from increasing to decreasing, there will be a local or relative maximum output values. If a polynomial switches from decreasing to increasing, there will be a local or relative minimum value. Let's look at how it happens here in the graph. So we have an endpoint, okay? One here towards A, this is point A. Towards the x-axis, this is point B. So that's exactly where the endpoint is located. This is where the local minima and the local maxima is happening. So the graph is decreasing and then it's increasing. Okay? From decreasing to increasing, you have a relative or local minima right here. From increasing to decreasing, you have a local maxima, or we say it global maximum. Remember, it says here that every global extrema or extrema is also a local extrema, whether that extrema is the minimum or the maxima. Maxima or maximum or minimum or minima. Then decreasing and increasing again, we have decreasing to increasing, we have a global minimum. So from increasing to decreasing, we have a local maxima. And this is the global minimum. All right? Global minimum is located here. Another term, we have a global absolute or extrema. When we say extrema, it's maxima or minima. Always remember that. Of all local maxima, the greatest is the absolute maximum. In local minima, the least is global or absolute minimum. Okay? Local minima, global or absolute minimum. Take note, global, absolute, local, relative. That is the other term. Because sometimes the question is asking for relative, that means it's talking about the local extrema. When it's talking about absolute, it's talking about the global extrema. Okay. The global happens when the maxima is at the greatest. Then you have a global maximum. When it's at the least, then you have the global minimum. Okay? Let's look at this. Two zeros, at least one extremum. Okay? At least one extrema. That is what it means. Whether it's maximum or minimum. So between two distinct real zeros of non-constant polynomial. So when we say constant polynomial, you just have a straight line. But when it's non-constant, of course, you have a curve that goes up or down. That is a non-constant polynomial. So there will be at least one local maximum or minimum. At least one extremum or extrema, maxima or minima. Okay. Another point that we have to consider here is an included endpoint. So if I have this figure right here on the left, I have one endpoint here towards the x that is at -1, and I have another endpoint here towards the x that is at +2. All right. An included endpoint of a polynomial with a restricted domain, because it has an endpoint. You don't have an arrow that extends through and have you an infinity, but it stops when it's at -1 and 2. May also have a local or relative extrema. Okay, we'll use that concept or the idea with this situation right here. Let f be a polynomial function with values of f of -2, 0, f of 0 equals 5, f of 4 equals 0, and f of 7 equals -1. Are there a guarantee extrema? So, are there an extrema in this case right here? Because if so, state where they occur. All right. If we try to look at, be sure we are having this concept right here. We could have an extrema if at least we have two zeros. We could have one extrema. So in this case here, we have to look for the zeros. We can find one zero here and another zero. When f is -2 and when f is at 4. So the interval is from -2 to 4. We have, because -2 is a 0 and 4 is also a 0. If we try to locate that in in a line, this is -2 here, 1, 2, 3, 4, and this is 4. This is where the zeros are located. While the rest you have when the function of 0 is 5. Okay, you can have 5 here, 1, 2, 3, 4, 5. And the other one, a function of 7, it's -1. So 4, 5, 6, 7, and it's -1. This is the other point. Where in this case, we found two zeros. So we can find an extrema. Okay? So what would that extrema be? It can be, a minimum or a maximum value. So there is, okay, at least one extrema on the interval -2 to 4. All right. If you have only one zeros, then you cannot have an extrema. Okay, it's not a guarantee that you can have an extrema when you have zeros. Okay. Even degree, absolute extrema. What is absolute again? It's global extrema. So if a polynomial has even degree, there is either an absolute maximum or absolute minimum. Even. So if your degree is odd, then there is no, okay? There is no maxima or minima. It happened when the positive leading coefficient, then you have a minimum. If the negative leading coefficient means you have an absolute maximum. Okay? Let's do this. Is there an absolute maximum or minimum for its function? So all you have to do here is to look at, I circled it already. The degree is even in number 1, and the leading coefficient is positive. Even degree, check. Positive leading coefficient, check. We have a minimum. Okay? Yes, there is a minimum. Okay? Positive, how does a positive looks like in a graph? If you try to graph, let's say both ends and points are facing up. Just say 1, 2, 3, 4, or have it this way. Just both are facing up. Both graph. Okay, so we have a minimum value. Oh, I should have done the graph. 1, 2, 3, 4. I have a minimum. I have a minimum. Okay. So here, 6 even, negative leading coefficient. So we have a maximum. Right here, negative, even, then you have a maximum. There is a maximum. So what's the arrow? Both are facing down. Okay, so if that is 6, we could say 1, 2, 3, 4. Okay, you can have that 1, 2 as your maximum. It's negative. It faces down. Now here, you have an odd. So that doesn't go with the, even degree absolute extrema. So none. No. It's not guaranteed. No maxima or no minima. Okay? 1, 2, 3, 4. Okay. Points of inflection. I think this term we did this already when we talk about concavity. But let's do it again. A point of inflection is a point on the graph of a polynomial function where the curvature of the graph changes. This point occurs when the rate of change of the function switches from increasing to decreasing or from decreasing to increasing. So this is where the graph of the polynomial function changes from concave up or to the concave down or vice versa, down to up. Right. Let's go over. So you can see a concave down here. You can say a concave up, and this is a concave down. So there is a switch, a change from up to down. So this is down, going up, going down. So where is that point that, change from up to down? This point right here. It's just like a divider. Divide the down to up, then up to down. And this is our point of inflection. All right. So right here, we could find our point of inflection right there. So this is facing up and this is facing down. So when there is a change from up and then it goes down, there, that point right there is what we call the inflection point or point of inflection. Here we have our point of inflection. This is down and this is facing up. So from down it goes up. The point of inflection is the one that the point where the change starts to switch from, from increasing to decreasing or from decreasing to increasing. Okay, let's do some exercise here. Let f be a polynomial function with the given values. Are there any guarantee of an extrema? Extrema meaning, are there any guarantee whether it's positive or, whether it's maximum or minimum? So as I've said, you have to look at two zeros. If your functions or the functions given we're having a 2, 0, then there is an extrema. Whether it's minimum or whether it's a maximum. All right. So what is the interval here? We have the function when it's -1 and when it's 6. That is the interval. Okay. So there is an extrema within that interval. Here, we found a 0, f of 10 is 0, f of 6 is 0. So there are two zeros. So the interval, in the interval of 6 to 10, okay, there is an extrema. Remember, the extrema happens when there are 2 points. Remember in the previous definition we did. So there is an extrema. In number 3, we only have 1 0. You should have at least 2 zeros to have an extrema. So there is none. No extrema, not a guarantee. You cannot guarantee that you have extrema, whether it's minimum or maximum. Is there an absolute minimum or maximum for its function? Remember the even degree in the positive leading coefficient and negative leading coefficient. So when the degree is 8, that means it's even, okay, and its positive leading coefficient, then we have a minimum, right? Because both arrows are facing up. This is the end point. I'm just doing the end point, so this is the minimum. Whether how many turns you have in your graph. Well, it's even degree and negative leading coefficient, you have a maximum. Because let's say I'm doing one endpoint here and the other endpoint, how many turns would that be? You have a degree of 4. So it's facing down. You have a maximum. Whether how many maximums you're going to have to the degree of 4. Here in number 3, you have an odd degree. So none. Okay? None. Alright? No maximum or minimum. Okay? No absolute. Say absolute global maximum or minimum. 6 degree even and it's negative, so both are facing down, you have a maximum. 6 turns, 6 curve. So I don't know how many maximum would that be. So we're gonna do the more on this, doing the turns of our polynomial functions later in our another video. Find the following extrema. Okay, let's do this. You have the graph. Okay, extrema, whether it's a local or a global. When we say, let's say absolute minimum, we have a point right here. So this is, where is this located? And we have an absolute minimum. I could have here. I found an absolute minimum. At what point? Located at -6. 1, 2, 3, 4, 5. Okay, this is at -5. Oh, this is -6. Wait a minute. The y is at -6. Okay. When the x value x is -5. This point is located at -5, -6. That is the location of the absolute minimum, or when you say global for other term. How about, do we have an absolute maximum? We could find at this point right here, 1, 2, this point. And this point. This is -2, 3. Okay, maximum of what? Negative or at +3 when x is at -2 or -2, 3. That's one maximum. How about the relative, local, or we could say relative? I would say minimum, relative minimum. I could have here when minimum is 2, 3. That's one minimum. When x is 2 and the y is -3. Maximum. what will be our relative maximum? It's still at negative 2 and 1, 2, 3. How about this? This is maximum. When x is negative, oh wait, I'm gonna write it here. When x is at negative 2 and 4. Minimum when x, okay, I will rewrite this. Minimum is found when x is at negative 5, right here. This is minimum. Local minimum, relative. Okay, this is local maximum. So when x is negative 5 and also when x is at negative 2, minimum. When x is 2, right here. Okay, this is the maximum when x is at negative 2 and at 4. That is the local maximum. Okay, let's do this. The last one. Okay, so we have this point right here. I will start with the global. I'm writing now some terms like global or absolute, because sometimes in a problem you are asked the global and it's about the absolute minimum of, do we have an absolute minimum when x is at certain point? I think it's none. Absolute minimum, but we have an absolute maximum. But this point right here, we have that absolute maximum of negative 1 in when x is negative 5, right here. And also when x is at 1, right here. You have the absolute maximum of negative 1, right there. Negative 1. So relative minimum. So I could mark here as the absolute maximum. Or global. This is also global maximum. Okay, relative minimum or local. Where can we find that? When x is at negative 3, right here. When x is at negative 3. I think this is the only one. This point is negative 3 in x and negative 5 in y. That point is where the local minimum is located. The relative maximum where is it? Here. This point, negative 5, negative 1. And also 1, negative 1. This is the relative maximum when x is negative 5 and when x is equals to 1. That is the location. When we say relative, that's the local minimum and maximum. But remember, a global extrema can be also a local extrema. All right. We'll have more on the local and global extrema or extrema. All right. Local and global extrema on my next video where I do problems and solutions. All right. And before I end up, I could say this: if I can do it, so can you. Please don't forget to hit the like button and subscribe button. See you in my next video.